All right. Hello, everybody. My name is Donny Wals. I am an iOS engineer who really loves testing and making sure that my code does exactly what I want it to do, when I want to do it, and just basically I want to make sure that I write whatever I need to write. So my talk today is called Adopting a Test-Driven Mindset in the Workplace. Because as much as I love to write tests and make sure that my code works, I cannot do that on my own when I am working on a project or working within a company. You need to have the team on board that you're in. You need to have as many people on board as possible, because otherwise you're never going to get a good test suite. I want to open this talk with a quote, and that's something that I have said countless times, and I feel bad every time I say it. Whenever somebody asks me, is the feature done? Does it work? Did you fix the bug? And I'll say, yeah, I think it works. That usually just is code for I kind of tested it, but I know that I didn't do enough to make sure that this does exactly what I want, what it needs to do. So my goal today is to try and transform that, yeah, I think it works, into a, I know it works through a test-driven mindset. Note that I'm not going to preach for test-driven development, because I'm not sure that that's the best way to go forward with testing, but a test-driven mindset. All right. So the goals as bullets. I want you to understand what it means to have a test-driven mindset. I want you to know what it means to be somebody who is thinking about testing a lot and actually implements it. I also want to show you how you can make testing a part of your workflow. Because if you don't make testing a part of your workflow, it's going to be really, really hard to have a good, reliable test suite. And lastly, I want to show you that testing can save you time in the long run. Because one problem that I hear every time when I talk to developers who don't test their code, it's testing costs too much time, and my project manager doesn't want to give me all that time, and it's really just something that we cannot do. And I firmly believe that when you do it right and when you make it part of your workflow, testing will save you time. So when you write features or when you write code, before you sit down at your computer, before you open your IDE, and before you start typing, you're going to want to gather requirements. If you don't have requirements, you're just typing random stuff into the computer. You don't know what you're building. You're just guessing at what it should be that you're writing, but you should gather requirements. So you should make that something that you do as a process. Now, to do that, you're going to have to talk to your stakeholders. And who are your stakeholders? Well, your stakeholders are pretty much anybody who can and will talk to you about product requirements. Typically, these will be people like product owners, project managers, designers, company owners, all that kind of stuff. And when you talk to them, don't expect that they will tell you exactly what the business logic should be. More often than not, you're just talking to somebody who has a fantastic idea, who has some sense of what should be done, and they'll tell you, well, this should kind of just work. And that's all they'll tell you, and it'll be a little bit vague what they really want. So what you should try and do is understand what the important parts are for your stakeholders. You need to try and understand what it is that they need you to build before you sit down and build it. Because they're just typically not very good at communicating technical details to developers if they're not a developer themselves. And your product owners and project managers should definitely be helping you out here. If you are the only one doing this in your company as a developer, it's going to be an uphill battle. So whoever is in charge of your planning, whoever is in charge of the project, should help you do this as much as possible. And when you talk to these people, you're going to want to formalize decisions, right? A lot of these decisions have already been made. They're just not formalized. They're not written down anywhere. So what you're going to do is you're going to do that. You're going to write down all the requirements, and all these requirements that you're writing down, all these questions that you ask, like, hey, what should this login form do if the user's password is only 4 characters? Like, is that okay or is it not okay? That's a good question that probably your product owner has thought about, but the CEO maybe just let somebody type in a password. I don't care what it is. Once you've decided that 4 characters is not enough for a password, write that down, because that's a decision that you made, and that is going to be the foundation for the tests that you're going to write later. And for every business rule and requirement that you determine, find some edge cases, right? I just said 4 characters is not enough for a password. Is 400 too much? Like, is there some cap of how many characters that we can store in that field? If so, make sure that you write that down. Right? Find out where this can break, where this can go wrong, where this can be incomplete, and fill the gaps. And I'll talk about this more later, but a language framework like Gherkin can help a lot there, because it will help you see what you're building, it will help you find errors in your reasoning, and it'll help you find edge cases. But again, more on that later. And once you've figured out what your requirements are, what is it that you're going to build, you're going to want to establish acceptance criteria. Now, ideally, these are somewhat already given to you in the process, but if not, make sure that they are clear. Because you need to know, when is the work done? When did I check all the boxes? Typically, this will be when all the requirements that we wrote down earlier are implemented, but you want to verify this. You want somebody to look at your requirements and look, okay, yeah, that's everything we need. And this is an interesting one. Figure out which tests are going to be run by your stakeholders. And that's not so that you can trick them into thinking that you did a good job and forget about the rest. It's because that helps you understand what's important for the business, what's important for the feature that you're working on. Because if they're only going to test like the happy path, you want to make sure that you also focus on the other things. So maybe tell them to like, hey, if you're only going to test the happy path, you're probably not going to test everything you need to do, because if you have users, everything that can go wrong will probably eventually go wrong. And refine your gherkins. So when you use Gherkin, that I'll talk more about later, refine them all the time. You need to update them as you go. Okay. So the review and refine phase. Do a final check, right? Make sure that all the cases are covered. Make sure that all the edge cases that you can think of are covered. Even if that means writing the exact same requirement twice with just one different word, make sure to do it. Because you want to have that checklist for yourself. If you don't write it down, you're going to forget it. I guarantee it. And make sure that errors are handled appropriately. It's so easy when you're thinking about a feature and what you're going to build to forget errors. And they don't have to be big, blow-up-in-your-face errors. They could be very, very subtle. Like, what if the internet connection drops during some transaction? Is that a problem or not? And what do we do if that happens? Do we automatically resubmit some form, or do we let the user do that? And make sure that everything you wrote down is unambiguous. Use strong language. Make sure it's clear. Like I said, if you have two very similar test cases, don't try to work that into one sentence. Write it down twice. Make sure that it's clear as day what you're trying to do. Okay, so when you're gathering requirements, let's sum that phase up. Talk to your stakeholders. Understand what they want and understand what they need. Formalize those decisions. Write down your business rules and use Gherkin for that. Also establish acceptance criteria. Understand how this product will be used, understand how it will be tested, and know when your work is done. And review and refine. This process of gathering requirements, you're of course going to do it up front, but you should not stop doing it once you start writing code. Keep refining what you're building and keep figuring out what it is that you need to do. Okay. Let's talk about Gherkin a little bit, because this is actually what I think is most interesting. It's a human-readable language to define behavior. And once you work with Gherkin, you'll find out that your whole workplace can actually help you with writing your tests. So let's look at an example of Gherkin. This could be a very simple login feature with two scenarios that are covered, one trying to log in with empty credentials and one trying to log in with a missing password. In Gherkin, we define a feature first. Basically, we kind of summarize, like, this is what we're going to be testing, this is what we're building, and it's sort of an overarching thing, like in this case, logging in is. And then you write down a scenario. What is it that we're doing here? Which flow are we going to test? For example, logging in with empty credentials. And then you start with three basic building blocks of a test. The given, what are we doing, what do we have, what are we looking at? A when, so what happens, what's the user input that we're trying to validate, or maybe it's some external event, maybe it's some webhook or whatever. And typically this should be a single action. Once you start writing down, if the user does this, and then does that, and then did that, and then did that, that's way too big. You're probably testing 5 features at once if you're writing the word and too many times in a when. And lastly, you have the then. That kind of describes the state the system should be in after this action was executed. So what happens to the system when the user taps on that login button, but they didn't fill out the form? Right, in this case, an error should be presented. and it should inform them of something. So you would test, like, is that error actually on screen? Does it contain the right body text and all that stuff? And again, here you don't want to have a million conditions. You should test like 1 or 2 things at most. So what's good about that? Why would you use this? Well, first of all, it's a solid foundation for your tests. Because even though what I showed you just now is not code, it's a test. It's something that you can translate to code relatively easily because it is structured and it's unambiguous, it's clear what you're testing. It also leads to a much better understanding of the system. These little gherkin feature descriptions, along with like some diagrams, could really make it clear what the system is supposed to do. And it will also make it much easier to discover missed cases or edge cases that you didn't cover in your requirements phase. And what's also nice, but it's not on the slide, is that because it's human readable, you can actually show this to your stakeholders. You can send them a document with all of these gherkin tests that you wrote and ask them like, hey, is this correct? Is this what we are building? Is this complete? Is there anything missing here? Is there anything that I wrote down incorrectly? And they can fix it for you. Like, they can continue working on this if they accept this idea and if they like how much better the process will be. Now, there are some potential pitfalls when using this process too that I have run into a bunch of times. First of all, it's not always easy to get stakeholder buy-in. I've run into scenarios where I would show this to somebody and they're like, you're the developer, I don't care. And I find it important to keep sharing these documents with people who don't want to look at them, because eventually they will start looking at them. They'll be like, oh, hey, maybe this guy isn't crazy at all. Maybe he's not wasting time. Maybe this actually made sense to look at before I told everybody to go and work on this. And another pitfall is that you might assume that your gherkins are complete and finished and done and that you don't need to refine them. Don't do that. Keep looking at them, keep refining them, keep improving them, keep adding new ones as you encounter things that you forgot. And don't take that definition phase that we talked about earlier too literally. Because if you do that, if you're like, I can only work on this now, and after that I cannot work on it again, things will get a little frustrating. You'll want to iterate on this the whole time. It should be a living document. And it's also important to remember that your stakeholders will often not consider themselves with deep internals of a system, right? If they will be more concerned about user interface, user flows, things that your user will encounter. And something like, if you want to test what happens if your disk is full and you cannot write to a database, probably your stakeholder doesn't care about that, but you probably do want to test that. You probably do want to make sure that you handle edge cases like that appropriately. So don't expect feedback on everything you write down, because they might not even understand what you're trying to test. So test-driven development, and we're close to seeing some actual tests and kind of see how I like to implement that. But I do want to talk about test-driven development a little bit, even though this is not the real topic of the talk. So a quick primer on test-driven development. I'm sure most of you know what it is, but let's go over it real quick. Step 1, whenever you're writing tests in a TDD environment, will be to write a failing test. After that, we're going to write the minimal amount of code to make the test pass. So that's not a complete implementation. It could be a single line of code that will just make the test green. Once we have a passing test, we will repeat, and we'll keep doing that until we're done. So an example of that, you could test that a login form throws an error if we have no credentials. This is Swift code, by the way, because I do iOS mostly. It's just a function that tries to create an instance of a login form object. However, because I do TDD in this case, I haven't defined login form yet, so this code would not compile, so it's a failing test. So I write my class, so I can create an instance of it, and my test now passes. It doesn't assert anything, it doesn't test anything other than I can create an instance of my login form. And I repeat, so I start adding things, like assert that calling a login function will throw an error, because I didn't set anything on it, so I implement a login function, I make it throw an error. Test passes. Now I check that the form username is nil, so it's empty, it doesn't exist. So I add that variable to my class, and I make sure that it can be null, and I run the test, and now it passes. And I keep doing this, right? It's very repetitive, it's very boring, but it does make sure that I test a bunch of things, right? I test that I can create an instance of my login form. I make sure that calling that login function can throw an error. I make sure that my username is optional and nil by default. I make sure that password is optional and nil by default. However, I don't test that I don't throw an error if I do fill out the username and password. I also don't test that the error for not filling in a username or filling in a password, or both, are different. I don't even test that I can assign a value to the username or the password. And there's a lot more that I don't test. So even though I went through a lot of cycles here, I didn't test much. But all the code that I wrote was tested. So what I like about this is that fact. All the code that I wrote was tested. It also provides a structured way to think about a problem, because you're solving the problem line by line. You're looking at your requirements, you're looking at your gherkins, and line by line you would be writing this down. And it's impossible to write code that is hard to test, because you're writing tests first. It does, however, take a ton of time, and if you're familiar with iOS development, I totally blame the Swift compiler for that, because you're going to be waiting for a minute or more every time you write a single test. So it's completely impossible to do TDD and not waste your time. And to me, it just feels silly to try and create an instance of an object that I haven't even defined yet, just to see that it's in fact not defined yet. So I'm just going to define it first. And it feels limiting, right? You're stuck in writing tests, and it's this back and forth, and it gets boring and slow and old real quick. So the way I like to do TDD, and I would highly recommend that, especially if you deal with compiled languages, it might make sense to do it this way. Start with a failing test. Write the minimal amount of code needed. You have a passing test, repeat. It's the same, except the way I do it is slightly different. So instead of writing this line by line, I would write all of these tests at once, implement the object all at once, because that would be the minimum amount of code needed to make all of those assertions pass. Right, my test passes, and I'm done. The things I test and the things I don't test are exactly the same in this case. However, it was much quicker to get there, so that's really, really nice. So this is all really cool if you're going to do something new, but a lot of us are working on existing code bases. So how do you test your existing code if you're not already testing it? How do you convince your manager to give you those 2-3 weeks, the month, the 2 months, that you would need to do a big refactor to make all your code beautiful, all your code testable, retroactively figure out requirements, apply them in tests? You're not going to get that permission. Like, nobody has time to halt development for months to make sure that you have a test suite. So how are you going to incorporate this? There's a couple phases that I would go through. First, preparation. Because you cannot build an amazing test suite overnight. It's not going to be one day work to get all your existing code tested if you don't already test your code. You can, however, start refactoring your code. So every time you work on something that's not really testable, make some small changes to make it easier to write tests later on. And of course, when you're working on new features, make sure that you work with your colleagues, make sure that you work with your team to get them to write requirements, to gather the requirements appropriately, to write those gherkin feature overviews, to make sure that everybody knows what we're doing. So for example, you might have this code, and this code would be really hard to test because it depends on the networking library in iOS without making that dependency explicit. So you could refactor this code, be a little bit longer, but now I could change what I'm injecting for my networking. Right? Because I defined a login service, which is an abstract class or a protocol, or however it works in the language of your choice. And this allows me to mock it in a test. Phase 2 is start small. Right? Don't try to refactor everything all at once. Don't try to test everything at once. Because there's no point in trying to do that. Especially if you're not experienced with testing, it's going to be really painful to test everything in one go. So also avoid complicated tests at first. Start simple, start small, start with things that might feel a little bit silly to test, where like, how could I ever introduce a bug here? Those are perfectly fine places to start practicing your test writing and to start refactoring your code base to be testable. Right, so for example, in this case, I have that login form again, and I started with a small test here, right? I'm just testing that I made a network call to my login service. I have the mock login service here, right, that implemented that networking part that I showed earlier. I have an asynchronous assertion here that makes sure that eventually we made a network call when we call login. It's not a fantastic test. It doesn't make sure that everything works fine, but it's something. And from here, we can start scaling up. We can start doing more complicated things. We can start figuring out more edge cases. We can start writing more gherkins. We can start improving our code base. Right? Tackle the more complicated problems. Figure out how you could fake the disk, figure out how you can test email sending, all that kind of stuff. And expand the test cases, right? If you had something simple, something small first, you're like, oh, there's a couple of edge cases here that are more complicated. Start doing those too. And also start thinking about integration tests, because unit testing and testing small bits and pieces is fine, but eventually you're going to want to make sure that your component doesn't just work on its own. You want to make sure that everything works when it's working together. So how do you get time to test? Right? Because I spend a lot of time talking about testing and about some perfect world, but we all need to convince our managers somehow that testing should be a priority. Well, let's look at some simple login flow, right? As an example. This diagram right here kind of shows a very basic login flow. It's not even complete. There's a bunch of boxes. There's a lot of arrows. Testing this manually would take a bunch of time, right? Because even just testing whether our email field is applying a correct validation, we're going to have to test a lot of inputs. We're going to want to make sure that we put valid emails, invalid emails, obscure emails, and there's even more emails than I have here that look completely invalid but actually are fine. And you would have to do that for every screen. Right? For every screen where you accept an email address, you would have to do this to make sure that you're using the correct component, that it's working as intended. When you're registering a user with first name, last name inputs, you would have to test a lot of different inputs here too, because people can have different names, if they even have names at all. And how long would it take you to test that by hand? It's not something that you would do in like 2 minutes. It would probably cost you half an hour to properly test all your login flows, all your registration forms, all your forgot password fields, just to make sure that they work. However, if these tests are automated, it's much quicker, and I can show you. Right? If you would show this to your manager, they would probably be very happy. So in this video, let's see if it actually plays. What we have is an app on the left where somebody's testing by hand, and on the right, just an automated test suite. So I started testing by hand, and I'm kind of just wasting time here scrolling on the other one, because it's going to be super fast. Build a project, run the test, done. All of the inputs that I showed earlier are tested, while the person doing it by hand is still typing. And this would run every time. So I don't know how your manager would think that you're wasting time by writing tests, because even writing the test once with many inputs is so much quicker than trying to validate all those inputs by hand. And you get the added bonus that you could run your tests on CI. So every time you commit, every time you push, these tests could work. And you could even run tests on set intervals. Like you could say, I want to run like some basic tests whenever I make a PR, but I'm going to run a long suite of integration tests every night. And that way you'll be confident that your code works every day, all day long. And CI is also the best way to make sure that your tests are run. If you don't have an automated process to run your tests, it's very likely that at some point, half of your development team is not going to run the tests at all, and the other half of them is going to run it all the time. So CI is a great way to make sure that everybody is on board. All right, let's summarize what we talked about today. Gathering requirements is vital to a good test suite, and actually this is where your test-driven mindset shines most. Because if you think about tests before you're even writing code, you're already writing tests as you are talking about requirements, as you are figuring out what it is you're building. Gherkin is a nice way to convert these requirements into something like pseudo tests, right? It's something that everybody can read, it's something that everybody can work on, and it's basically already coded or already codified in a way that you can just translate to whatever language you are writing. If you have an existing code base, start refactoring it first. Make sure that it's ready to be tested before you start testing it. That way you don't have to ask for weeks of time from your manager. You can just tell them, hey, I'm going to refactor bits and pieces for every 30 minutes that I have free. Actually, we should be refactoring anyway, so you're going to be doing this no matter what. And testing manually takes way more time than doing it automatically. That doesn't mean you shouldn't ever test manually. It should be a part of your process. But testing automatically saves you time in the long run. And when you do everything correctly, writing your tests is not even something that should take you more than, let's say, 30 minutes extra per feature that you're working on. All right, that was my talk. Thank you so much for attending. Thanks so much for listening. And have a great rest of your day.
Ladies and gentlemen, hands together.